Welcome to lesson 68. This is going to be a 4-parter. This is the first part. We're going to talk about the locus definition of a parabola. The locus definition of a parabola says that a parabola is the locus or the location of all points that are equidistant from a given point called the focus and a given line called the directrix. So below I have a screenshot of a parabola with its focus and its directrix plotted. So the focus, here's a point here. It's going to be on the inside of the parabola. And this focus, it doesn't matter where on the parabola, whatever point you choose, it is going to be the same distance from this point to the parabola as it is from a perpendicular line from the directrix to that same point on the parabola. So from the focus to the parabola to the directrix, that perpendicular line there, those are going to be the same length. Those are going to be congruent. That is how we find a definition, a locus definition for a parabola, by its location in relationship to a focus point and a directrix line. So it doesn't matter where you go. If I were to draw a perpendicular line here to the directrix, all right, that's a perpendicular line, from this point to the focus, this is going to be congruent to this line here. This line is going to be congruent to this line. So the distance here is the same as the distance here, and the distance to here is the same as the distance to here. So that is what your directrix and your focus, that's a relationship between the two. And as the distance between the directrix and the parabola increases, so does the length from the parabola to the focus. They are always going to be the same distance and congruent. So now you know what the focus and the directrix are. How do we find them? So we have specific formulas for the directrix and the focus, and I'm going to give them to you here. So the graph, this is what our function looks like. It's y is equal to, let's say, ax squared, where a is the coefficient for the x squared term. So this is a parabola function. That is what it looks like. So the vertex is here. It's 0, 0. Its focus is going to be 0, p. So the focus is going to be formatted as 0, p. So we have to figure out what that is. The directrix is going to be y is equal to negative p. And a is going to be equal to 1 over 4p. So what we have to do in order to determine, I'm sorry, this is the directrix. In order to determine the focus and the directrix, we have to find the value of p. And that is going to be determined by taking the a, the coefficient, subbing it in here, and then solving for p. And then we take that p value and we substitute it in here and here. So let's go into a practice problem and do that. All right, so 68.1 says to find the focus and directrix of y is equal to 3 over 7 x squared. That's our parabola. So we are going to apply that to all of the information that we have, all the formulas we have to find the focus and the directrix. So we know that in order to find p, we have to take a and apply it to this formula here. So that's our first step. We would set that up as 3 over 7, that is the a value, is equal to 1 over 4p. We know when we have a pair of fractions set equal to each other that we cross multiply. So 12p is equal to 7. P is equal to 7 over 12. So our focus for this is going to be 0 and 7/12. And our directrix is going to be y is equal to negative 7/12. Now we're getting to the point where we need to start using decimals so that we can graph this. It's going to be really hard to graph this otherwise. So we are going to divide this, and when we do, 7 divided by 12 gives us 58.583333 repeating. So for a repeating decimal, just give me that last decimal. So the focus would be 0 and 0.583, and the directrix would equal y is equal to negative 0.583, and that would be enough to make me happy. All right, now when you get to college, your professor may ask you to put that repeating line above the 3. If you do that, that's fine. I'm not sure if you have that repeating line in Jupyter. I'll have to, if it's not there, I'll have to double check it. I think that you can use the line segment button for that. Let's try that and see what we can get if we have that repeating decimal come up. All right, I'll give you both options whenever we get there until you get in the habit of doing the way that we decide. Whatever way we decide, that's the way we'll do it from that point forward. Okay, so let's do another one. So here is 68.2. It says the focus of a parabola is 0 and negative 5/3, and the vertex is at the origin. So find the equation of the parabola. So if the focus is 0p, then we can safely assume that we can insert negative 5/3 in for p wherever it applies. If the formula or the equation for parabola is y is equal to ax squared and a is equal to 1/4p, then we can set the equation as y is equal to 1/4p is negative 5/3, and then x squared, because this would be the value of a. This is our formula for a. We're going to take this value of p, which is right here, and sub it in for the p in this formula, and this value for a will sub it into the parabola equation. So we're just backtracking a little bit. So now all we have to do is multiply. So we're going to say y is equal to 4 times negative 5 is going to be a 1 over negative 20/3 times x squared. So we know with multiplication or division of numbers and fractions that we can keep it, change it, flip it. So I'm just going to do that over here to the side. 1/1 times 3/-20 becomes 3/-20. And we shift that negative symbol to the top because we know we multiply the whole thing by -1, and that will take care of that. So y is going to be equal to negative 3/20 x squared. And that would be the equation of the parabola who has a focus of negative 5/3 as the y term. All right, and that is all we have for 68A. We're going to have a couple practice problems, and then we'll go into 68B, translated parabolas. So far what we've been doing is where the origin of the parabola is at 0, 0, or the vertex of the parabola is at 0, 0. Now we're going to shift our parabolas around a little bit and do that. But first let's practice some like this with the origin at the vertex.